कि जो हम आज कोकिंग कोल इंपोर्ट करते हैं, हमारा इंपोर्ट बिल 72,000 करोड़ से ज़्यादा है साहब। 75% हम लोग जो इंपोर्ट करते हैं कोकिंग को वो ऑस्ट्रेलिया से। पिछले अक्टूबर महीने में मैं रूस गया था। हम लोगों ने एमओयू किया कि रूस से भी हम लोग आगे आने वाले समय में 40 मिलियन टन तक हम लोग जो है कोकिंग कोल इंपोर्ट करेंगे। लेकिन कोकिंग कोल ही एक बहुत बड़ा हमारा जो है समझिए एनर्जी का वहाँ पर सोर्स हो जाता है, जो हम लोग जब स्टील का मैन्युफैक्चर करते हैं। और पूरा का पूरा जो हमारा DRI है साहब, जो पिग आयरन हम बनाते हैं, आप सब जानते हैं किस प्रकार से हम लोग कोल का यूज करते हैं और कितना जो है हम लोग जो हमारा जो कार्बन का जो इमिशन है, जो हमारा वायुमंडल है, कितना प्रदूषण होता है। आज भी देखिए जो स्टील का उत्पादन करते हैं तो पोल्यूशन कितना बढ़ता है। पूरी दुनिया में इसका कंसर्न है और अपने देश में तो पूरा ही कंसर्न है। हमारे माननीय प्रधानमंत्री जब आप जानते जब गए थे तो 2070 तक कार्बन न्यूट्रल होने का उन्होंने कमिटमेंट रखा है। लेकिन हम सब भारतवासी, जो हमारा राष्ट्र का एक गौरवशाली इतिहास है, हम चाहेंगे कि 2070 तक हम क्यों प्रतीक्षा करें। हम जितना जल्दी हो उसको करें, जिससे कि आखिर ये जो प्रदूषण होगा उससे सबसे ज्यादा प्रभावित कोई होता है तो हमारी धरती माता होती है और हम लोग सब इससे प्रभावित होते हैं। इसलिए जो ये प्लास्टिक है और कोई भी वेस्ट साहब तब तक वेस्ट रहता है जब तक उसको आप वेस्ट की तरह ट्रीट करते हैं। जैसे ही आप उसको वेस्ट को, जो हमारे प्रधानमंत्री जी कहते हैं कि वेल्थ की तरफ ले जाते हैं, तो पूरा का पूरा ट्रांसफॉर्मेशन हो जाता है। और यही जो अगर आप देखिएगा कि जो हमारा यूज प्लास्टिक है, जिसको हम लोग सिर्फ रिसाइकिल करते हैं, और स्टील है जहां पर कि अब फाइनल इनका डिकम्पोजिशन हो जाएगा और ये हमारा जो कोकिंग कोल है या PCI है उसको रिप्लेस करेगा, तो हमारे लिए एक बहुत बड़ा सोर्स ऑफ एनर्जी होगा। और जो हम आज जिसकी चर्चा आपने बड़ा अच्छा किया कि हम लोग क्या पूरी दुनिया का बात कर रही है कि साहब ग्रीन स्टील होना चाहिए। आप देखिए यूरोपियन कंट्रीज को, आप देखिए जापान को, आप अमेरिका को देखिए, हम लोग को रोज पाठ पढ़ाता है। पूरी दुनिया को प्रदूषित कौन किया और हम काहे पीछे रह गए। हमारा हिंदुस्तान पीछे क्यों रहा? क्योंकि हम लोग बीच में जो इंडस्ट्रियल रिवोल्यूशन हुआ उसको मिस किया। हम डिजिटल रिवोल्यूशन मिस नहीं किए हैं, लेकिन इंडस्ट्रियल रिवोल्यूशन हम लोग मिस किए और इसलिए हम लोगों को गुलाम होना पड़ा था। क्या जो हमारा म्युनिसिपल पूरा का पूरा जो वेस्ट है उसमें हमारा जो प्लास्टिक है, मैंने एक स्टडी को देखा था, करीब करीब 19 से 20 मिलियन टन का उत्पादन होता है। मैंने उत्पादन क्या होता है, वो कचरा के रूप में आता है। अगर साहब 50% भी अगर हम लोग इसको यूज करने की सोच लें, उसके लिए पूरी स्ट्रेटजी बना, सिर्फ सोचने से काम नहीं चलेगा। आज आप देखिए जो म्युनिसिपल वेस्ट हमारा जो प्लस है उसका कलेक्शन का होना चाहिए, फिर उनकी प्रोसेसिंग का होना चाहिए, फिर उनका लोकेशन होना चाहिए, जिससे कि हमारे जितने भी स्टील मैन्युफैक्चरर हैं उनके पास क्वालिटी का जो हमारा प्लास्टिक है वो उनको उपलब्ध हो सके। आज आप देखते हैं स्टील में भी आप देखते हैं कि हम लोग बेनिफिशिएट करते हैं और पेस्ट बनाते हैं। आगे आने वाले समय हमारा जो प्लास्टिक वेस्ट है इसको भी हम पेस्ट बनाते, तो निश्चित रूप से इसका उपयोग होगा और इससे पूरा विन विन सिचुएशन सब मिलेगा। आप बस 1 मिनट के लिए सोचिए, मुझे तो बड़ा अच्छा लगता है साहब कि आज जो पूरा का पूरा शहरों में नाला सब चौक रहता है। क्यों? कौन दोषी है? प्लास्टिक। क्योंकि इसको आप फाइनल डिस्पोजल नहीं कर पाते और जब ये खत्म हो जाए, और आप देखिए पूरे देश में कहीं आपको दिखे, मैं तो गांव से आता हूं, एक भी किसी भी लोहा का या किसी भी मटेरियल का कोई स्क्रैप बचता नहीं है गांव में भी। रोज कबाड़ी वाला उसको खरीद करके ले जाता है। ग्रामीण इलाकों से लेकर करके हमारे जो पूरा का पूरा जो म्युनिसिपल का एरिया है, शहरी इलाके, सब जगह लोग इसके बारे में कॉन्शियस हो जाएंगे, कलेक्शन करेंगे, लोग उसका प्रोसेसिंग करेंगे तो कलेक्शन इंडस्ट्री हो जाएगी। हमारी स्मॉल स्केल इंडस्ट्री है, उनको भी बड़ा काफी इससे फायदा होगा। तो ये मैं देख रहा हूँ कि जब हम लोगों को जो हमारा कमिटमेंट है कि कार्बन इमिशन को कम करना है, हमको कार्बन न्यूट्रल 2070 के पहले हो जाना है और स्टील हमारी ग्रीन हो जाए, इसके लिए सबसे जरूरी क्या है कि जो हमारा प्लास्टिक वेस्ट है इसको वेस्ट ना मान करके, इसको वेल समझ करके ठीक से प्रोसेसिंग करके इसको स्टील इंडस्ट्री में लगाएं, जिससे सबके लिए फायदा है। तो मैं आज फिर सबको बहुत बहुत शुक्रिया अदा करता हूं। और मैं एक चीज चर्चा से पार करूं, मैं गया था जो हमारा JSW का प्लांट है हम्पी में, जानकर प्रसन्नता होगी कि वहां मुझे बताया गया कि जो उनके पास प्लास्टिक उनके कैंपस में और आसपास हो रहा है उसको अपने वो प्लांट में उसका यूज कर रहे हैं हमारे देश में। टाटा भी आप जानते हैं, वो लोग एक्सपेरिमेंट बेसिस पर कर रहे हैं। जापान के बारे में आपने सुना, और भी कंट्रीज है, तो टेक्नोलॉजी भी है। तो हम सब लोगों को मिल करके एक साथ बढ़ना है, जिससे कि हमारा प्रधानमंत्री जी की सोच है कि हमारे भारतवर्ष को एक सशक्त राष्ट्र बनाना। तो सशक्त हम लोग इसमें भी हो कि हम लोग कैसे अपना जो हमारा कार्बन इमिशन कम हो और हमारा जो वेस्ट है उससे हम वेस्ट बना पाए। बहुत बहुत धन्यवाद।
जो कोई भी विषय को एक चालना देने की जरूरत पड़ती है तो ये एनर्जी लगती है सर। इस एनर्जी से सारे जो पैशनेट टू से ऑल दिस व्हाट यू हैव सेड, वी हैव नोटेड डाउन एवरीथिंग, we'll try to do justice to all the points that you have raised to a large extent within the conference, but if not, I'm sure we'll take it forward at the industry sector as well to ensure to convert this particular plastic waste into a resource. You talked about iron, the way iron gets recycled and supply chain is developed. I think there's also a need for plastics to happen, and that will happen when market forces should work towards bringing a value to this particular material. It's very interesting, and you have said it very rightly, sir, that when the value is seen, the employment, the people will start running around. And that will develop a great deal of employment for the masses, for all kinds of stakeholders in the masses, whether it is learned and maybe not so learned people, but still the employment generation will certainly happen. The aspiration that our country has set, our Prime Minister has announced about 2070 being the carbon neutral. I'm sure we are all there to take it forward, and this deliberation, I'm sure, will help pave the way towards that. So thank you very much, sir. Okay, so we are going to talk about in this panel greening the steel making process by using plastic waste. Quickly, if you look at the plastic waste, this is the data which has been compiled for the global, for the entire globe. There is some data available for India also, but you can see what I'm trying to show here is the magnitude. You have 300 million tons almost, plastic waste which gets generated, produced. And when we talk about the packaging item of that is almost about 78 million tons. And almost everything, unfortunately, once the consumer has utilized, tends to get into the environment. There are recycling processes which are set in our country, and we are very proud of that. To recycle this material, there are several supply chain processes which have come in place for the recycled material. Mr. Manish is here. There are several other plastic recycling processing industries are here who are recycling that material and not allowing it to go. And they actually are representing about 14% of the total plastic, which is actually non-recyclable. The packaging one, sorry. Then there is a lot of it, which gets burned or also sent for energy recovery. That is roughly about 14%. Almost 40% gets into the landfills because there is no value for that. And that is a cause of concern because through the rains and through the water, they go into the ocean that we talked about. And the last is leakage, about 32%, we don't know what's happening to it. There's also going into the environment in some manner. So when we talk about greening the steel, there are several industries who are coming forward now. I'm very happy ArcelorMittal is there on the dais. They have said that they want to, become carbon neutral by 2059. One way to do that is to utilize the alternative materials and not the fossil fuel. And obviously plastic is one. Voestalpine, I've seen the plant where they have also been utilizing large amount of plastics in the steel manufacture. There are many companies globally, Japan, as Minister Sir was talking about, like you have NKK, you have JFC Steel, Molycop in Australia, they are all utilizing plastic waste as a source for as a reductant source in the manufacturing process. This can be utilized in blast furnaces as well as in electric arc furnaces, and large amount of plastic waste which is getting generated in India therefore offers potential for utilization in our steel industry, because we are second largest producer of steel. We also produce large amount of plastic waste. There is a fantastic synergy available for us to put it together. In the blast furnace, I just wanted to highlight a few things. For smelting of iron ore for production of pig iron, traditionally coke is used. As the Minister Sir has already said that we spend crores of rupees in importing the coke from Australia. And obviously the requirement is to generate carbon monoxide and heat so that we have a reducing environment for the manufacture of steel. But if we can replace that with plastics, you are able to actually reduce that coke utilization to a large extent. That's the opportunity that we are talking about. The types of plastics which will be used in blast furnace, almost everything. Even if it is PVC, it can be, but to some extent, there are some, difficult issues. Probably my colleagues from SinghMinister and from Tenova would be able to highlight something. So, for certain reasons, we don't want to put the chlorine into the system, substantial chlorine into the system. But yes, all kinds of plastics can be appropriately managed. There's enough temperature, there's enough residence time, there's enough opportunity for it to get completely, utilized without any cause of concern. If you look at the blast furnace, there are methodologies of injecting this plastic waste into the furnace and gainfully utilize it. When I say gainfully, there are locations in the furnace where there is a good use possible, most efficient use possible, and those technologies have been researched. A lot of development has happened, and these can be implemented, and more developments are also happening. A lot of research is happening on that. If we look at this particular number, I was told, and I tried to calculate, and I was very much there. 3 million tons of steel. If you are producing almost 6 lakh tons of plastic, we can utilize. To that extent, the opportunities are 20% of the steel which is produced. Probably plastic can be replaced there and utilized. And this is the calculation which I tried to do just for my understanding, and I find that for India, the capacity considering 100 million tons of steel, probably 25 million tons of plastics possibly can be utilized. So there is a great opportunity available for utilizing these plastics. So I thought I'll just share a few thoughts. Sir Shri Sendhu, he is from ArcelorMittal, and what I want to ask you, Mr. Chattopadhyay, is what are the different technologies where this particular material can be appropriately utilized in steel industry, and then what are the key quality requirements of the plastics that you talk about? Maybe if you will highlight that, then I'll pose a few more questions to you. And if you are okay, sir, on the panel, I would go panel by panel so that we can conclude the deliverable of the panel in an appropriate manner. So over to you, Mr. Chattopadhyay.
Thank you, sir. See, plastics can be used in different processes of steel making. It can be used in coke ovens. It can be used in blast furnace. It can be also used in electric arc furnace, and it can also be used to some extent in the coal-based sponge iron plants. Out of this, coke oven is the oldest and the most popular method in many countries. Normally, it is used in the range of 1% of the input coal, because if you try to increase the plastics more, then the coke quality properties goes bad. So around 1 to 1.5% of coal can be replaced by these plastics, and this translates to roughly 5 kg of plastic per ton of steel from the coke oven itself. In addition to that, in the blast furnace, it can be injected, companies like JFE and Kobe Steel, they have been using injection of this plastics in blast furnace, and they claim they can use up to 30 kg per ton of steel in this material. However, the actual data in the Japan is blast furnace injection is roughly around 4 kg per ton of steel. In electric arc furnace, it can be around 1 to 1.5%, where it is used as a foaming agent. And about the conventional sponge iron plants, this needs to be studied because this is not very well known, but still there is some opportunity there. Having said that, so India is producing around 110 million tons of steel.
So that is, so you know, from the figure that I said about 25 million tons, we have already achieved 3 million tons or 3.5 million tons, right?
It is a possibility.
Okay, obviously, of course. We have to establish the process. We have to, you know, ensure that, you know, we are comfortably able to feed the material. We may need some infrastructure and a lot of other things associated with that. Certainly, I agree with you. But my joy was that, you know, there is certainly a possibility of doing a reasonable quantity, and 3 million is not a small amount of plywood area. So, looking at this particular opportunity, you know, what do you think are the quality requirements, you know, for the plastic waste? And what do you think the stakeholder segments need to do, or the authorities need to do, you know, in terms of pushing this particular activity in our steel industry?
So to answer the question, first question, plus quality requirement, one of the key quality requirements is that it should not have chlorine. What happens is when we feed it into the blast furnace, this chlorine becomes the plastic. Chlorine comes out of the plastic, and then it eventually forms HCl at different parts of the furnace. Plastic is used. Mostly PET is not used in steel making. It is separated because it fetches more value if it is recycled in other way. So what is being normally put in is the packaging and packaging material, and out of this, roughly 50% is used in the iron and steel industry. And the key requirement here is that it should not have chlorine. The other requirement is that size. So normally when the material is being fed into coke oven or into blast furnace, it should have a size of 3 to 10 mm size. And this is normally done by heating the plastic and then extruding or granulating it so that the size range is achieved. So these are the two requirements, two key requirements, and of course there should not be contamination, there should not be any mud, metals, all these things should not be there. So that is anyway should be a prerequisite. Coming to the government policies, when I asked my colleagues of Nippon Steel, what do you think should be done in India? They said that key enabler in Japan has been the plastic and container recycling law. This has been utilized, and because of that only they are able to recycle the plastic in the steel plants. Actually, I had a slide. Can that slide be shown? It's the law gives a responsibility of extended responsibility to the users. Similar thing is there in Japan. But what is somehow not there is who bears the cost of recycling. So I got a statistics, it was there in the slide. In 2019, the Recycler Association of Japan collected roughly around 38.6 billion yens as a fee from the designated organizations. This was then passed to the recyclers. So they recycled around 0.95 million tons of plastic that year in 2019, and if I just divide it, it comes to around $365 per ton of recycled plastic. So this amount of benefit the recyclers are getting. So that makes the recycling business encouraging, because as it has been discussed earlier, shorting is a big problem. So unless, and it is totally a manual process, and unless it is done at every stage, from the consumer level, the municipality level, shorting will not be proper. And in fact, my colleagues from the council say that they always had some problems which had to be sorted out regarding the quality consistency, because shorting was not proper. So if this shorting has to be done properly, manpower has to be put in, the cost of plastic, as we see, recycled plastic will go up very significantly. We did an initial checking with our local suppliers. They said that if you want a shorted material, sir, the cost of plastic will go double or triple. In fact, my Japanese colleagues have told. In the European, there are also scenario. There are issues like they have a carbon. They have an overall target of reduction of carbon, and if they if they are able to reduce the carbon by plastic, which is slightly having more of hydrogen, they get some benefit out of it. So these are the benefits that the government actually passes on to encourage plastic recycling. The statistic shows that there were, for every 10 municipalities, there is one recycler. Whereas I checked in Gujarat, for 27 municipalities, there are 813 recyclers, registered plastic recyclers. Now, for a company like ArcelorMittal Nippon Steel, it's difficult to engage with very small players. So there has to be big players with scale where we can engage and get the material on a consistent basis.
कि मैंने एक पाउच खाया और एक कहीं पे फेंक दिया, उससे क्या होता है? You know, just one pouch of my biscuit, उससे क्या फर्क? I feel that awareness कि आपका एक पाउच कितना वैल्यूएबल है. You know, that one pouch, हम सब अगर सोच के वो एक पाउच को ना डाले या डाले तो सिस्टमेटिक तरीके से अगर उसका रास्ता बैठा है, तो that half of the problem will be solved. The problem what we recyclers are facing, why we are needing high-end technologies, are because of those contaminations. Once the contaminations are not there, our Indian machines are well equipped to handle all these things. We are needing those Italian machines, those German machines, because of the contamination, because of the mixed plastic. So, the most important thing is the awareness which should be there throughout the people in our country. That is the most important key point which I feel as a hurdle in recycling industry, you know. And anyways, now plastic waste is going in cement lanes. There also these type of issues are coming up. Some vehicles are not even accepted because of this contamination. So this one point, if we can work on this, you know. And since we are sitting with a platform of, serve with steel industry, I just got a thought just now sitting over here, that the same iron material, which is a low value material, can be converted into stainless steel. It can be converted into stainless steel. Just as far as my knowledge goes, you have to just take out the oxygen and you have to insert carbon. So the same material becomes a very expensive material. The same iron is becoming stainless steel. So I just got a thought now, you know, in our plastic scrap also, if the awareness is inserted, among the people, among the recyclers, and the misconceptions are removed, the same waste can be a valuable product. How the iron is becoming the stainless steel, it's a big problem.
Okay, so you raised 2 points, Mr. Manish. One is, of course, the segregation and giving sort of respect to the waste, so that it doesn't get contaminated willfully, because that's what is happening today. And the second important thing you talked about is giving some value addition, so that its price can be upgraded in the process, so that this is more. So very good idea. I think that makes sense. And I'm sure, slowly and slowly, as the awareness, government is taking a lot of effort in trying to bring awareness about different kinds of plastic materials, their impacts. Even children, schools, are also doing that activity. So I'm sure the day is not far when, the things will start moving. As is happening with the recycled material, recyclable material, so also will happen with the non-recyclable material. I think that's what we believe. So, by the way, is Professor Veena available online? Kind of a platform, right? But nevertheless, I think that's very important. So even if it is, kind of pushed ahead one step, it also makes a lot of sense. So in terms of the electric arc furnace, or in terms of blast furnace, when we want to start utilizing, what do you think, the steel industry should be looking for? What are the requirements that are there? Also, in terms of what are the kind of arrangements that possibly they may have to do? Are there any challenges that you visualize, for the steel industry, and if you have any suggestions on overcoming them?
So, as Mantriji has told in the beginning, that we are moving from a linear economic to a circular economy, in which the waste is not simply a waste, but it is a raw material for the next production cycle. So coming to the steel, then I will come to the plastic. So yeah, everybody here knows that the steel industry accounts to about 7% of the greenhouse gas emission, and already most of the people are working towards the green steel. Dr. Kumar is fully aware that we are also working in the green hydrogen, green steel making, even the scrap utilization. That is also considered scrap recycling. So likewise, plastic also comes into the picture. But all the plastic cannot be used, as rightly mentioned by Mr. Sithindu, and Manishji also here is sitting, he also understands that the most important thing is the correct management and recycling. That should be the approach. Now, as we say plastic, we generally in the steel sector, if you ask, mainly for the electric arc furnace or iron and steel industry, because we are the technology provider for the steel industry as well as in mining. So we call this material as a SRA. SRA means secondary raw material, secondary reducing agent. We never call it as a plastic or polymer, because there is a difference between a plastic and secondary reducing agent. I am taking an example of Italy, where plastic is totally banned because there is a guideline. We cannot put the plastic inside the steel making because it will involve a lot of poisonous gases. So there is a norm. So likewise, since Mantriji is also here, there should be a policy defined in India also that such type of plastic should be used for making the steel. What is SRA? Basically, SRA, 2-3 things are very important, which Mr. Shindu has already mentioned, that it should be considered as a reducing agent, not an energy source. That is first thing, and there should be proper way by which the plastic should be converted into SRA, that is secondary reducing agent. And definitely with the help of Mr. Manishji, those things can be, definitely it is possible. The second most important aspect that has already been touched upon is the chemical composition, that is chlorine, metal, those things has to be taken it out. Then, because if we are not doing it, those material will create poisonous gases like dioxins, and then it will create environmental hazards. Because in the steel industries, these arc furnace and those things are not designed to handle, address this dioxin, because they are having the back filter. So those things we have to take it out. So yes, it is true that we can use the plastic which are in the packing industries or food industries. There is no chlorine or any hazardous material present there. The advantage of SRA as compared to a typical carbon, it has got high calorific value. SRA is basically a processed plastic. By various process we convert into SRA. SRA is secondary reducing agent, and that should be allowed to be used in a steel sector. It has got high calorific value, low sulfur content. That is also beneficial in the case of we do the ladle refining in the secondary metallurgy. There is low carbon content. Of course, this will help for the reduction in the CO2 footprint, carbon footprint, and it has high hydrogen. Hydrogen, as I was mentioning this, hydrogen and carbon monoxide. These are the two gases which are reducing agent. Normally in blast furnace, there is carbon monoxide we use for reducing the iron oxide into iron. Likewise in DRI, natural gas based or whatever the gases, there is a hydrogen component. Nowadays we are working on the green hydrogen, that is electrolysis from the renewable energy like wind or solar, and generating the electricity, and those electricity will go inside the water and it will create hydrogen, and then hydrogen can be utilized as a reducing agent. It is the best reducing agent, and by default in such plastic we are getting that hydrogen component. It is acting as a reducing agent that definitely helps in reducing the carbon footprint. Then, as Mr. Sindhu was also mentioning, this it is used for the slag foaminess inside the electric arc furnace, which is really beneficial for the production point of view. So,
Capability within ASEAN, we are the second largest producer of steel. We have actually improved the efficiency of the steel production in the country. A lot of things we have done in terms of improving the technology, in terms of efficiency, etc. On this front, what is your take on that?
you are absolutely correct. We have, as you was mentioning, that yes, there will be hydrochloric acid and reduce the life of the water-cooled ducts because of the corrosion. So there is a alternate method that we can also inject lime, so that will neutralize because that is basic. So those things are fine tuning has to be done, because I have seen whether in Australia, where Ms. Veena will also tell, they are putting the, I have seen it, a distance between the steel level as well as the point where the injection is taking place. So an angle, as you rightly mentioned. So those equipments can definitely be done, only fine tuning, because these are based on our experience and technology. Providers like us will definitely give a value addition to Mr. Sindhu if he allows us to do a trial in his own plant.
Sure.
With the help of Mr. Manish ji, we can produce that desired material and we can show the performance.
Perfect. That's a very positive answer, and I'm sure we can take it forward very soon. Minister sir had already said, we have actually lost the industrial revolution. We were lost into the industrial revolution without contributing anything. We did do that. We did, face that problem with the digital revolution. Right? So in terms of this, adapting to these new technologies, adapting to this, environment, management system, etc. What are your views? How do you want to look at it? How should we take forward this particular initiative? What should be the way, we should take it forward? Are there any thoughts on that? I can tell you from my experience of doing things in cement industry, when the first question came that can we utilize plastics in cement, we said yes, we can. What needs to be done? We said we just have to set up a system and start feeding the system into this and ensure that we are not causing any problems, so we have the right environment, understanding, etc., etc. We did the trial, and we were able to successfully demonstrate that it's safe to do that. And then there was no looking back. A lot of material started moving to the cement plants, a sort of small supply chain. In cement, there is a difference as compared to the steel. In cement, even if the plastics is contaminated with other materials like cloth, paper, resin, leather, rubber, etc., which are combustible but not really plastic as such, it doesn't matter. But in steel, probably it might. And therefore, as Mr. Manish was saying, we have to have a proper segregation processes in place so that the right material with right quality enters this thing. So from that consideration, I would like to ask, what should be the way forward? How do you think we should take it forward? May I start with Mr. Manish? Can you say कि भाई किस तरह से we'll take this particular initiative forward? हमको तो सीरा जैसे बताया सर ने 3 मिलियन टन तो करना ही है, as soon as possible.
That itself will solve the maximum problem of the waste that our country is having. Is there? We all are aware of it. So if we come to know from these people from the steel industry that actually what is going to be the requirement, we can start working on it. And of course, with you, Ullas sir, the most talented mind who has started using of plastic in the cement plants, definitely this industry is going to be a superb opening for the plastic recycling people. Things what are it can be a new route altogether for every one of us. And I don't find everything is just an idea, you know. Now, after this EPR has come into the movement, from the big brands, it's become a mandate to use the recycled polymer. Now, the government has made the mandate, but our country is not equipped to give that type of quality to the brand people. So the things have been sorted out, but do we have the raw material? Do we have the technology? I think ma'am has joined.
Yeah. That's where I was coming to. So thanks for saying this. You know, if these stakeholders come together,
Exactly.
right, and if they start discussing,
Yeah.
then what is your requirement, whether I can fulfill that or not? And if I can fulfill that, what I need to do, what you need to do. If that understanding starts happening, I think the movement towards the objective will start becoming far, far simpler and smooth. So we have, Professor.
Connectivity, but these things happen. So thank you so much for being so patient and for having me. I guess the simple answer is, here in Australia, when we first developed green steel, the partnership with industry and our industry partners who have now commercialized the technology, we've been very committed to working together in a collaborative manner, which means that not only are we doing, of course, lab-based scientific testing, but also industrial scale application. And that's important because as results come out of the lab, very rapidly we're able to deploy those on production furnaces. And the benefits that you see, you actually see those evidence very quickly. So I guess the approach that we have taken with our industry partner with polymer injection technology is to be able to have diversity in the kinds of feedstock we can use. And it's always about hybrid feedstock. There's no such thing as one perfect answer. And depending on the furnace, depending on the operations, you can actually get really good outcomes, particularly in the context of introducing more hydrogen into steelmaking furnaces. And this is what polymers do really well, is version of our solution has now commercially been proven. The ability to tailor that depending on the kinetics, the speed of reaction, the utilization, and the ability to improve, of course, various reactions inside the furnace. So ultimately, it's all about productivity and getting the best environmental outcomes. And we know that when we start to use hydrogen inside these steelmaking furnaces, depending upon, of course, how you apply that waste resource, you can actually get a win-win outcome, a better outcome for steelmakers, but you also get better outcome from a recycling point of view. So that partnership in Australia has been absolutely critical for us to commercialize this technology.
That's very interesting. I think, and that's what we were discussing also, probably, that the stakeholders need to come together. There should be a partnership approach, there should be a win-win approach. Then the things will start happening. Joint, actually, Veena, there were also some concerns about the emissions, from the process of utilizing plastic. What is your experience in that, in terms of that? Can you elaborate, please?
Yeah, no, thank you for that question as well. I mean, these are critical questions because at the end of the day, we want to achieve positive outcomes for the environment. That's the bigger picture goal of why we're talking about recycling plastics, why we're looking at using it. So the science actually proves that when you're using it in a certain way, and that's why it's not just what you're using, it's how you're using it that matters. And it's not just to say, well, any old plastic will do, any old way of using it will do. The ability to create the right feedstock of the right chemistry and the right way of using it, so therefore the kind of thing we talk about with the injection technologies, are about ultimately breaking down those molecules through those smaller and smaller, as we know, requires reducing agents. And this is why typically, of course, we use 4 and 4. But the fact that you can bring hydrogen molecules to be utilized in the most efficient manner possible, there is that total consumption, and this is why, of course, when we talk about what you use, how you use it, to be able to give you the best possible efficiency gains in this method. That's really the goal. How do you get more fair outcomes from a given furnace? So how do you bring together both productivity questions as well as the best possible recycling outcomes? And this is where the science has already been proven to deliver this. And this is why I was saying that when we were first funded to do the scientific study, it was Industrial and Research Council, a lot of that science has already been published in peer-reviewed scientific journals, and that has got all the answers to some of the future questions. And so therefore the next step, of course, is what we are doing now, is working in deploying these technologies in Australia and in other parts of the world.
Sure. So, put into the steel making process, So there is, Mr. Chattopadhyay was saying that it could be about 3.5% in that range of the total mass which is getting into the kiln. From my experience in cement, I can tell you that, we started with something like less than 1%, and then we said now we can scale it up more. We went on to 5%, then we also 10. There are countries in the world where it is almost 90% utilization, of the fossil fuel replacement. And we are not talking about in the replacement, and you have corrected me several times during our discussions. So we are not talking about replacing coal from the fuel point of view, but as a reductant, as Mr. Chaturvedi also said. From that consideration, what I want to know from you is what is the volume, either per ton of steel or any other manner that you can give us, so that we can start aspiring towards that.
Because I think to me that really does come down to, of course, when you talk about using plastics, bearing in mind that you just heard earlier, it's not just the 1:1 replacement of coal, which is that carbon from coal that was, it's also hydrogen, and then it could also have other hybrid feedstocks included. You've got reduction of iron oxide, you've got also, don't forget, carburization, right? When you think about, iron that is reduced, if it is carburized to about 3 or 4% carbon, you can also use it as a carburizer. So there are many functionalities of what you want your polymer to do. So we have actually shown that with all of these functionalities, whether it's reduction of iron oxide or it's carburization, you can actually bring in more of these materials. So I would probably say that there is no doubt that as we are towards zero coal, we want to get to zero coal. That's the goal with our partners in Australia for the next part of the community. But that zero coal across the board is for that carburization function, as well as, of course, for reduction function. And you can certainly achieve that depending, of course, upon the level of carbon content and the amount of reduction agents that we use for your operations. So absolutely achieving that goal of replacing each of the functions depends upon the nature of the plastic that you're using. Not to say that all plastics will do a perfect job, I just want to remind everyone. Plastic, depending upon the nature of the plastic, their functionality and the performance will be different. So you've got to be very careful and wise in the way you select the right one for the right purpose.
That's very interesting. The ingredients, the constituents, their percentages, their benefits that we want to derive, and based on that, then we start looking at how much we should. And objective, of course, is to ensure that we are gainfully utilizing every molecule of the material that we are putting into the system. So thank you very much, Veena. I think that's very useful to us. I know we are closing to the time. We are already short, I think. So what I want to do very quickly is to summarize, to say that, of course, there is a great potential of utilizing this material in the steel industry. The things have to start working towards that. And for it to happen, obviously, there is need for having collaborative approach, sharing approach, understanding approach of each other's needs, because these stakeholders that we are talking about are completely alienated from one another at this point in time. For example, steel may not know what happens in plastic industry. Plastics may not know what is requirement for the steel industry. So there's a lot, I think, needs to be churned, discussed, understood, and then something needs to come about. Then also there's a requirement, as was mentioned by the panel, that there has to be some kind of facilitation which has to happen from the ministry, from the policy point of view. Like Mr. Chattopadhyay was saying that in some country, probably in Japan, there is some regulation which has been put in place so that it facilitates that process of collection, transportation of the material. So to the industry submissions as to how we can take this particular forward, that actually speaks the passion that you have to solve this problem of plastics and to green the steel. I'm sure this actually is coming from our Honorable Prime Minister's kind of vision.
Have a big round of applause for Ullas, sir. Thank you so very much. On that very note, a big round of applause to all. Yeah.
You see, this year the production of crude steel is 120 million tons. And by 2030, we are targeting 255 million tons of crude steel. So if you see, if it is 3%, so you see the consumption of plastic. If it is 1%, even then, the quantum is really huge. So you have a great potential for utilizing plastic as a source for manufacturing for steel. That is what I have to say.
Thank you. Thank you so very much, everybody. Again, sir, thank you so very much for your time. This is to please present the momentum. Thanks, everybody. Thank you so very much, sir, once again. And last but not the least, thank you so very much. Dr. Sumanthai Manas Bhushan, sir, please join us for the program, please. Sir.
Yes.
Thank you so very much. On that note, I would request each one of you to please kindly take your seats. Thank you.
Then it takes only the white one. Yes. It takes the black. Then how about like two colored only? Then how? You have a completion here.
You want green, you can set green. It will accept green
And the senses it.
camera. It is basically a camera.
Machine. Yes, sir. Wet wash plant.
There is a computer inside.
Can I have your card? Sure. Where do you make this?
This is cut city cuts. This is like after crushing. This is after crushing. That can do up to 3 ton per hour. Even 16.
And then this one makes
दिल्ली में लीला होटल गुरुग्राम में एक कॉन्फ्रेंस जो प्लास्टिक के ऊपर रिसाइकल के बारे में हुई है, उसमें हमारे यूनियन मिनिस्टर फॉर स्टील रामचंद्र प्रसाद जी यहाँ आए थे। उन्होंने इस कॉन्फ्रेंस में बहुत सी बातें कही हैं और प्लास्टिक को रिसाइकिल के बारे में बहुत कुछ बताया है। लेकिन आइए हम यहाँ पर श्री साइकिल प्लास्ट LLP में श्री वास्तवा जी यहाँ पर हैं, उनसे जानना चाहते हैं कि ये जो आपने मशीन यहाँ पर इंडिया में आप इंपोर्ट करके लाए हैं चाइना से, तो ये किस तरह से काम करती है और कितना जो रॉ मटेरियल को किस तरह से रिसाइकिल करती है?
ये स्पेशलाइज्ड टेक्नोलॉजी है जो यूरोप से भी आती है, चाइना से भी आती है। और मशीन काम ऐसे करती है, बेसिकली कलर सॉर्टर है। तो इसमें कैमरा होता है, कैमरा इमेज लेता है और इमेज को कंप्यूटर प्रोसेस करके पता लगाता है कि कौन सा कलर है। उसके हिसाब से जो कलर हमें चाहिए होता है उसको एक अलग जगह पे डालता है और जो नहीं चाहिए होता वो रिजेक्ट करके दूसरी जगह पे डाल देता है। इसको बेसिकली सॉर्टिंग कहते हैं। ये ऑटोमेटिक सॉर्टिंग है और बहुत हाई स्पीड से होती है। अलग अलग कैपेसिटी की मशीन है, 1 टन पर आवर है, 2 टन पर आवर है, 3 टन पर आवर है, 6 टन पर आवर है, लाइक दैट। इसी तरह दूसरी मशीन है हमारी जो अलग अलग पॉलीमर को भी अलग कर सकती है।
तो ये मशीनें आपकी बाहर से ही आप इन पे वर्क कर रहे हैं या कुछ इंडिया की मशीनें भी हैं और वो भी काम कर रही हैं? आपने सब
इंडिया में भी मशीनें हैं, लेकिन ये हाई टेक्नोलॉजी का मटेरियल है की मशीनें हैं। अभी इंडिया में डेवलपमेंट हो रहा है, ऐसा नहीं कि नहीं हो रहा है। इंडिया में काफ़ी डेवलपमेंट हो रहा है, कई मैन्युफैक्चरर्स हैं और हाई एंड मशीन होने की वजह से वर्ल्ड के बड़े मैन्युफैक्चरर्स हैं, उनकी मशीनों में रिलायबिलिटी फैक्टर ज़्यादा है। धीरे धीरे हो सकता है 1-2 साल में इंडिया की मशीनों में भी रिलायबिलिटी फैक्टर बहुत आ जाए और बहुत बिक भी रही है इंडिया में मशीनें, कलर सॉर्टर वगैरह बहुत बिक रहे हैं, ऐसा नहीं है।
श्री वास्तवा जी बहुत बहुत धन्यवाद, आपने मशीन के बारे में जानकारी दी। और यहाँ 2 डेज़ का कॉन्फ्रेंस है और यहाँ पर जो मिनिस्टर जी ने बताया है कि किस तरह से हम प्लास्टिक को रिसाइकिल करके बहुत सा इसमें डेप्थ है, बहुत अच्छे काम इसमें हो सकते हैं। आपका बहुत बहुत धन्यवाद।
थैंक यू वेरी मच। थैंक यू वेरी मच।
आज हमारे बीच मनीष सिंह जी हैं जो उत्तराखंड से बेसिकली, और प्लास्टिक को रिसाइकिल करने के लिए उन्होंने अपनी मशीनें लगा रखी है उत्तराखंड में। प्लास्टिक को किस तरह से रिसाइकिलिंग करते हैं और उसके बाद उस वेस्ट प्लास्टिक से क्या बनता है, आइए हम मनीष जी से जानना चाहते हैं। तो मनीष जी आप हमें बताएंगे कि आप यहाँ पर जहाँ पर अभी रामचंद्र प्रसाद जी यूनियन मिनिस्टर फॉर स्टील आके कॉन्फ्रेंस को संबोधित कर चुके हैं, बहुत सी बातें उन्होंने बताई हैं। तो अभी आप बताएंगे कि किस तरह से आम जनता के लिए कि प्लास्टिक से क्या क्या बन सकता है।
बेसिकली हम पशुपति ग्रुप काशीपुर से हैं। बेसिकली जो हमें प्लास्टिक का रिसाइकिल करते हैं पेट, PP और SDP में, इसका हम दाना बनाते हैं। जो हमारे घरों का वेस्ट रहता है उसे हम इकट्ठा करके पोस्ट कंज्यूमर और पोस्ट इंडस्ट्रियल वेस्ट से दाना बनाया जाता है और उसे फिर बाज़ार के अंदर दोबारा से रीसेल करा जाता है। जिससे कि जो लैंडफिल होता है, जगह जगह प्लास्टिक का कचरा पड़ा रहता है, वो सब इकट्ठा होकर हमारे पास आ जाता है और फिर वापस मैन्युफैक्चर को वापस सप्लाई करके उससे दोबारा प्रोडक्ट बन जाता है।
सर जी किस तरह से ये काम करता है प्लास्टिक को, किस तरह से आप पहले प्लास्टिक आया फिर आप टुकड़े करते होंगे फिर मशीन में डालते होंगे, तो क्या होता है सर?
ये हमने पोस्ट कंज्यूमर वेस्ट से ही सारे जनरेट किया हुआ है, जिसमें हमारा ये फाइबर है, पॉलिस्टर फाइबर अलग अलग कैटेगरी में होता है, जो मतलब टॉयज फिलिंग के लिए काम आता है, पिलोस के लिए आता है, अलग अलग कैटेगरी। और ये यहाँ भी जनरेट बनता है इससे, तो जिसमें कि हमारे जो मल्टीपल प्रोडक्ट हैं सभी इसमें यूज होते हैं, चाहे वो मास्टर है, चोपेट, फ्लैक्स हो, ग्रेनुल्स हो, PP के आइटम्स जो भी बनते हैं जो मार्केट में आते हैं वापस, वो इन्हीं की वजह से मिलते हैं, चाहे वो टैंक हो।
तो मार्केट में आप ये जो चीज़ें हैं ये दे देते हैं आप, और उसके बाद जो है और इस तरह के काम करते हैं, इसको लेके वो कई चीज़ें बना सकते हैं इससे।
मार्केट में हम 2 तरीके से सप्लाई करते हैं, एक तो इस फॉर्म में, ये हो गया फ्लेक्स फॉर्म में, एंड देन दाने के फॉर्म में, एज पर रिक्वायरमेंट।
दो फॉर्म में आप इसको देते हैं?
बिल्कुल, दोबारा से हम यूज़ कर लेते हैं। इस तरीके से हम देश को स्वच्छ बनाने का काम कर रहे हैं।
मतलब आप इसमें एक तो स्वच्छ भारत जो गांधी जी का सपना था कि स्वच्छ भारत का, और अभी मोदी जी ने कहा है, नारा लगाया कि स्वच्छ हमारा देश होना चाहिए, उसके लिए आप पूरी भागीदारी है आपकी। और डिजिटल इंडिया बनाने की भी मोदी जी का जो सपना है उसको साकार करने में आप सब जुटे हुए हैं।
हम सब जुटे हुए हैं।
सुनील चौधरी और मनीष सिंह जी ने बहुत अच्छी जानकारी दी है सभी के लिए, और हिंदुस्तान को स्वच्छ बनाने के लिए जो इन्होंने मुहिम चला रखी है। प्लास्टिक जो है हमारे देश का एक बहुत बड़ा एक किस्म का धब्बा है इस प्लास्टिक को ख़त्म करने के लिए इस तरह से जो लोग सामने आते हैं उनका बहुत बहुत धन्यवाद। और मोदी जी ने जो सपना देखा है स्वच्छ भारत का, उसको साकार करने के लिए सभी का सहयोग और सभी का साथ ज़रूरी है। थैंक यू वेरी मच। बहुत धन्यवाद।
लिख दो ना, अरे लिख दो ना, लिख दो काट के अपना वीडियो भेज देंगे।
वेस्ट मैनेजमेंट के ऊपर आप क्या कहना चाहते हैं?
Very good afternoon. So this is Melvin and Prem from South Tamil Nadu, Coimbatore. So and basically we are a tech waste management company. So and what we do is like so we handle pre and post consumer waste. Pre waste is like industrial waste management, and pro consumer is post waste consumer is like for APM. And so basically like we have an authorized recycle vendors for Pan India, and we take industrial waste which is going to landfill, and we directly take it and we recycle it into our value added products. So that's how we work, and like so we work all this through a technology called this is our technology application. So it's like completely like booking a Ola. So just like you are like booking a Ola through an application, so you can swipe up and like you can send your all the industrial waste out of your factory by just clicking one button. So this is all about the our application and platform.
ओके, थैंक यू वेरी मच। बहुत बहुत धन्यवाद। थैंक यू सर। थैंक यू। शेरी
इसमें मिक्स क्या किया हुआ है? इसमें केमिकल्स होते हैं, ये इनकी R&D अपनी है। एक सेलर है जो कि हमारे प्लेटफॉर्म लेके अपने प्रोडक्ट में सेल आउट कर रहे हैं हमारे प्लेटफॉर्म, राइट। एंड आफ्टर दैट ये क्या बायोडिग्रेडेबल है? हाँ मैम। पर ये इसमें प्लास्टिक भी होगा? प्लास्टिक इसमें नहीं है, इसमें सिर्फ और सिर्फ इसमें प्लास्टिक बाइंड कैसे किया हुआ है? ये मैम केमिकल केमिकल फिर पूरा बायोडिग्रेडेबल नहीं हुआ ना 100%। और ये जो है बेसिकली जैसे गाँव में होता है कि टेम्परेचर मेंटेन करके रखना टेम्परेचर के लिए, ये रबर विद डस्ट, ये भूसा है। ये रबर है? रबर से बना। रबर में आपने बेसिकली हस्क मिक्स कर बायोडिग्रेडेबल भी है और वैसा भी नॉन वर्जन भी। ये यूज़ कहाँ होता है? ये यूज़ जैसे कि आपका विलेज एरिया में होगा। कहाँ विलेज में? कहाँ विलेज में? जैसे कि वहाँ पे जैसे पहले लोग मिट्टी के घर बनाते हैं, तो अब टेम्परेचर कम के लिए कि टेम्परेचर कम मेंटेन भी रहे और फिर वहाँ पे बनाया जा सकता है। रोड पे बनाया जा सकता है। रोड पे सर इसकी हीट करने की टेम्परेचर इसमें टेम्परेचर कम होता है। ये रबर और काफ़ी चीज़ें इसमें मिक्स है। इसकी R&D मेरे को एक्चुअली काउ डंग हो तो समझ में आता है, मिट्टी को मड से हल्का रहता है, कि रबर तो
क्योंकि रोड जो बनते हैं वो तो गर्म हो रहे हैं धूप में।
चलिए ठीक है, वो R&D का डिटेल शायद नहीं है आपको
हाँ, वो आपको वेबसाइट पे आपको मिल जाएगा, हमारी क्लाइंट डायरेक्ट आपको प्रोवाइड भी करते हैं। एंड ये सारी चीज़ें ये टाइल्स
ये आपके क्लाइंट्स के हैं?
हाँ, ये हमारे क्लाइंट्स है, हमारा प्लेटफॉर्म है। और ये टाइल्स भी है, ये FRP है, राइस है, इसमें मिक्स है।
ये क्या है?
ये भी सर ईट है आपको।
FRP क्या होता है मेरा?
FRP मैम इसका तो मुझे आइडिया नहीं है, आपको वेबसाइट पे आपको चेकआउट वेबसाइट वाली बट ये हमारी क्लाइंट है, ये हमारी प्रोडक्ट, ये अपने सभी प्रोडक्ट हमारी वेबसाइट पे सेल आउट करते हैं, जो कि आपको सारी चीज़ें वहीं पे आपको मिल जाएगी।
ठीक है, मैंने आपका डिटेल ले लिया है। कौन है फाउंडर इसके? गौरव कौल। कहाँ पे बेस्ड है ये? दुबई बेस्ड।
पीयूष जी, यहाँ पर प्लास्टिक रिसाइकलिंग के बारे में जो कॉन्फ्रेंस हुई है, जिसमें प्लास्टिक के ऊपर बहुत सी बातें कही हैं, तो यहाँ पर आपका जो ऑनलाइन पोर्टल है फॉर रिसाइकलिंग इंडस्ट्री, इसके बारे में आप क्या कहना चाहते हैं?
एक्चुअली मैं आपको बताना चाहूँगा कि हमारी पोर्टल है जहाँ पर रिसाइकलिंग इंडस्ट्री के लिए इंडिया का वन ऑफ द बेस्ट पोर्टल है, पूरे वर्ल्ड का बेस्ट पोर्टल है, जो कि आज तक रिसाइकलिंग इंडस्ट्री में किसी ने कुछ किया नहीं है। और राइट पे अवे कि हमारा इसमें बायर्स और सेलर्स को आपस में कनेक्ट करने के लिए, वेस्ट मैनेजमेंट इंडस्ट्री को कनेक्ट करने के लिए बनाए गए, जहाँ पर बायर्स मैनुअल वेस्ट जनरेटर, वेस्ट कलेक्टर, इन सब चीज़ों में करते हैं। और आप यहाँ पे देखेंगे भी हमारे प्लेटफॉर्म पे, जिसमें कि मैन्युफैक्चर है, वेस्ट जनरेटर है, स्क्रैप के हैं, मशीनरीज होती हैं, राइट, एंड लाइसेंसिंग का पूरा एक इकोसिस्टम बनाया गया है, प्रॉपर साइकिल बनाई गई है, जहाँ पर लोग आके आपस में खरीद और बेच सकें। नेटवर्किंग क्रिएट की गई है, जहाँ पर एक क्लिक में ही एक वेबसाइट है हमारी, राइट, जहाँ पर एक क्लिक में एक पूरा का पूरा इवेंट की जरूरत नहीं पड़ेगी, जिसमें कि आपस में लोग कनेक्टिविटी है, क्योंकि आज के डेट में हर चीज़ का कनेक्टिविटी है, बट लेकिन रिसाइकिल इंडस्ट्री को कोई मेनली फोकस नहीं किया। वी आर द वन, हमने इस चीज़ को फोकस किया और हमारे कलीग सर हैं उन्होंने फोकस किया, और जिसमें कि ये आपस में आके कनेक्ट होंगे। और सभी आप जैसे कोई मुंबई में है, कोई दिल्ली में है, बवाना की एक
ऑल ओवर इंडिया में जहाँ जहाँ भी रिसाइकलिंग का फैक्ट्रीज है लगा रखी है लोगों ने, वो सब आपस में वर्चुअली
कनेक्ट हो जाएंगे और क्वेरीज जनरेट होंगी आपस में। किसी को कुछ चाहिए, जैसे कि वेस्ट जनरेटर को वेस्ट कलेक्टर चाहिए, तो वो सारी की सारी रोड बैग पिकर हो गए, तो सारी की सारी आपस में कनेक्ट हो जाएंगे, जिससे
हाँ, तो बात आसानी से एक दूसरा समझ सकेगा, बताई जा सकती है। नहीं तो कॉन्फ्रेंस में बहुत दिक्कत होती है, एक स्टेट से दूसरी स्टेट आना, टाइम वेस्टिंग। आपने बहुत अच्छा शुरुआत की है, बहुत बहुत धन्यवाद। आप कॉन्फ्रेंस में यहाँ पर पहुँचे और आपने इस तरह से लोगों को अवेयरनेस के लिए इस तरह से आपने ऑनलाइन पोर्टल की शुरुआत की है। बहुत बहुत धन्यवाद। थैंक यू वेरी मच।
थैंक यू सो मच।